Have you ever gazed at the night sky and wondered about the mysteries it holds? Imagine a canvas painted with the darkest hue of black, dotted with glittering specks of light. That's our universe, a vast expanse of enigma and wonder. Among its countless marvels, one phenomenon stands out for its sheer spectacle and power: the supernova. Supernovas, these celestial fireworks, are not just visually magnificent, they're also the source of some of the most profound elements in the universe. They're the climax in a star's life cycle, marking the end of one journey and the beginning of another. Their tale is one of transformation, of energy, of elements. It's a tale as old as the universe itself, and one that never fails to captivate us. In the grand theater of the cosmos, supernovas are the ultimate crescendo, a dramatic finale to a star's life. So let's dive into the fascinating world of stars and their dramatic ends. Every star begins its life in a similar way. Picture a nebula, a vast expanse of space dust and gas. Here, gravity pulls these particles together, creating a dense nucleus that starts to heat up. As this process continues, the core of this celestial body reaches extreme temperatures and pressures. This is where the magic happens. Now imagine hydrogen atoms, the most abundant element in the universe, colliding at such high speeds that they fuse together. This process, called nuclear fusion, transforms hydrogen into helium, releasing a tremendous amount of energy in the process. This energy is what makes a star shine, illuminating the cosmos with its radiant glow. Yet this spectacle of light and heat is just the beginning. After millions of years, the star settles into a stable phase, a balance between the inward pull of gravity and the outward push from fusion. But this stability won't last forever. Like all things in the universe, stars too have a lifespan. But unlike the fleeting existence of a mayfly or the century-long life of a giant tortoise, stars live for millions, even billions of years. They're not eternal though. They age, they change, and eventually they die. Stars are essentially cosmic furnaces, burning nuclear fuel at their cores. This nuclear fusion is their lifeblood, creating the energy that makes them shine so brilliantly against the backdrop of the cosmos. But every furnace eventually runs out of fuel, and stars are no exception. When a star exhausts its nuclear fuel, it starts to cool down. As it cools, it begins to contract under its own immense gravity. This contraction triggers a chain of events that leads to the star's demise. As the star shrinks, the pressure and temperature at its core rise dramatically. For a while, this increased pressure allows the star to burn what little fuel it has left at a faster rate, making it shine even brighter. But this is a star's last hurrah, its final brilliant blaze before the inevitable darkness. Eventually, the star can no longer sustain nuclear fusion. The outward pressure that kept the star puffed up against the crushing force of gravity disappears. What happens next depends on the star's mass. If the star is small or medium-sized, like our Sun, it will shed its outer layers and shrink to a dense core, becoming a white dwarf. But if the star is massive, it will collapse under its own gravity and explode in a brilliant supernova. But the death of a star isn't the end of the story. It's the beginning of something much more spectacular. When a star dies, it doesn't go quietly. No, stars are not ones for subtlety or gentleness in their final moments. Instead, they go out with a bang, a cataclysmic explosion of energy and light, a spectacle that briefly outshines an entire galaxy. This is the birth of a supernova. Let's break it down. The life of a star is a delicate balance between gravitational pull, trying to squeeze the star into the tiniest space possible, and the force of nuclear fusion, pushing outwards and keeping the star puffed up. As long as these two forces are in equilibrium, the star lives on. But alas, nothing lasts forever. When a star exhausts its nuclear fuel, fusion ceases. Without this outward pressure, gravity takes over, causing the star to collapse under its own weight. But the star's core resists, resulting in a bounce back that sends shockwaves rippling through the rest of the star. This triggers a chain reaction, igniting the remaining fuel in a brilliant explosion. This explosion is what we call a supernova. It's not just any explosion, mind you. It's an explosion so powerful that for a short period it can outshine the combined light of all the stars in its galaxy. And what's left after the dust settles? Well, if the star was massive enough, its core would collapse into a neutron star or even a black hole. but the rest of the star is blown out into space, creating a beautiful nebula of gas and dust. This material then becomes the building blocks for new stars, planets, and maybe even life. So a supernova is more than just the death of a star, it's also a birth of sorts. It's the universe recycling itself, taking the old and making it new again. A supernova is one of the most violent events in the universe, a fitting end for a star. Supernovas are not just beautiful, they're also incredibly important. They are the grand finale of a star's life cycle, and yet they are only the beginning of another cosmic story. These celestial fireworks, as mesmerizing as they are, play a pivotal role in the grand scheme of things. They are cosmic forges where elements heavier than iron are created. Yes, that's right. The gold in your jewelry, the copper in your coins, even the calcium in your bones, they were all once part of a supernova explosion. Supernovas also seed the cosmos with these elements, sprinkling them across the universe where they form new stars, planets, and even life itself. They are the universal architects, shaping galaxies and star systems, including our own. So, in a way, we all are made of stardust, born from the heart of a dying star. So the next time you gaze at the night sky, remember the stars and their explosive ends, shaping the universe as we know it.